Hello there, welcome to Creative Tech School. In today's class, we'll be talking about a very interesting topic, which is IP address. Now, if you're a networking student or you have any plans of doing networking, you can actually be good in networking without understanding IP addressing. Without an IP address, two devices cannot communicate. So today we'll be looking at an IPv4 IP address, and we're looking at everything about an IPv4 address in general. So the things we'll be covering includes the following. Okay, we'll be covering what an IP address is in general. We'll be covering different versions of IP address. We'll be looking at an IPv4 address and how it is actually structured. We'll be looking at the classes of IP address, and we'll be looking at the types of IP address, and we'll be looking at subnetting in general. Now, the first thing we'll be looking at is what is an IP address. Now, an IP address is a logical address assigned to a network device to enable communication. Now, one thing you need to understand is that without an IP address, two networking devices cannot communicate. There are two versions of IP address. Now, the first version of IP address is your IPv4. The second version is your IPv6. Now, an IPv4 address is 32 bits long, while an IPv6 address is 128 bits long. Now, in today's class, we'll be looking at IPv4 address and everything about an IPv4 address in general. An IPv4 address, it uniquely identifies a network interface on a machine. An IPv4 address is written in decimal digits. It's formatted by 4 8-bits and separated by a period. Now, each 8-bit represents a byte of the IPv4 address. There are different classes of IP address. The first class of IP address we have is our class A IP address. The second class is our class B IP address. The third is class C, class D, and then class E. Now, your class A IP address has a pattern of 255.0.0.0, and the first byte decimal range is from 1 to 7. Okay, and then your class B IP address has a range of 255.255.0.0, and the byte range of 128 to 191. Remember, IPv4 address has 32 bits, and the 32 bits is later broken down in 4 portions. So now, the first portion is this portion that we have here. So in a class A IP address, the first portion is actually turned on, while the remaining 3 octets are turned off. While in our class B IP address, the first octet and the second octet is turned on, while the third and the fourth octet are being turned off. For your class C IP address, the first, second, and third octet are turned on, while the last octet is turned off. While your class D and E are not yet in use, they are reserved for multicasting, and class E is experimental and is used for only research. Now, we have different types of IP address. We have a private IP address and a public IP address. Now, for a private IP address, these are addresses that we use in our local networks. Now, for your public IP address, these are addresses that you use to access the internet. Now, you can see an illustration that we have over here. We have a laptop, and the laptop is in an office. But before the laptop can have access to the internet, the laptop has to have a public IP address. But for the laptop to communicate with other laptops in the same company complex, the laptop will do so using a private IP. So that is one thing you need to understand about public and private IP addresses. Now, the question is, what is subnetting? Subnetting stands for sub-network. Now, in other words, subnetting acts as a way of breaking down your network into smaller networks. It's a process where we borrow portions from our host and give to our network. Now, one thing you need to understand about subnetting is that an IPv4 address is made up of 32 bits, as I said earlier on. And each 32 bits is divided into 4. And 4 of those bits are broken down into 8 bits, and each of the 8 bits is referred to as an octet. And the value of the octet is 128, 64, 32, 16, 8, 4, 2, and 1. Now, the sum of this octet gives us 255. Now, total sum of the octet is 255, 255, 255, 255. So when each octet is turned on, it gives you a sum of 255. So now, we'll be looking at Class C IP address in general and subnetting in Class C IP address. Now, one thing you need to understand is that an IP address is divided into 2. The first portion belongs to your network and the second portion belongs to your host. So we'll be looking at how we can subnet this IP address and how we can calculate the number of usable IPs within this particular subnet. One thing you need to understand is that when we subnet, we borrow a portion from our host and we give that portion to our network. That there's a formula for calculating number of hosts, and the formula is this: 2 raised to power n minus 2. This is the formula that is used to calculate the number of hosts. Now, n represents the number of unused bits, while to calculate the number of subnets you have 2 raised to power n, where n represents the number of borrowed bits. Now we'll be working with a Class C IP address, and for a Class C IP address it has a prefix of 24 because remember 3 of the octet are turned on while 1 is turned off. Alright? So now, calculating the number of hosts for a Class C IP address, we will get a result of 254. Now, the reason being 254 is because we have 2 raised to power 8. Now, where does this 8 come from? The 8 now that we're having here represents the 8 bits of our host portion which we haven't touched. Now, the 8 bits is what we have here. So 2 raised to power 8 gives you 256. And when you minus 2 from 256, you get the result 254. So by default, a subnet 24 will give you 254 hosts per subnetwork. So now we'll be subnetting to subnet or prefix 25. And one thing you need to understand is that prefix 25 has a subnet mask of 255.255.255.128. And why is that so? The reason why it's 128 is because right here you can see that all these bits right here are turned on, but the last portion that belongs to the host now, only 1 bit is turned on, and that 1 extra bit is what makes it 25. Before now, 8 plus 8 plus 8 gives you 24 plus 1, which gives you 25, and the value of this 1 bit right here is 128, and that is why we have a subnet mask of 255.255.255.128 for prefix 25. And remember, this portion belongs to your network, and while this portion belongs to your host. So now we'll be looking at calculating the number of hosts per subnet and the number of available subnets on prefix 25. So now the formula for calculating the number of hosts remains the same: 2 raised to power n minus 2. In this situation, we have borrowed 1 bit from the 0 that used to be here, So right now we have borrowed 1 bit here. So what does that leave us with? 7 bits. So you can see we have 1, 2, 3, 4, 5, 6, 7. So we're having 2 raised to power 7, which gives us 128 minus 2, which gives us 126. So the number of hosts we have on prefix 25 is 126. Now for subnet, number of subnets we have on prefix 25, the formula remains the same. Formula is 2 raised to power n, where n in this scenario represents the number of borrowed bits. Now for us to get 25, we borrowed 1 bit from this host portion. So now we are going to have 2 raised to power 1. 2 raised to power 1 gives us 2. So we have 2 sub networks. Now we'll be looking at how to calculate range of IP address in IPv4. Now we'll be working with subnet 25. Remember that subnet 25 has a subnet mask of 255.255.255.128. Now the 128 in subnet 25, that 128 is our host portion. Alright? Now that 128, we are going to subtract it from a constant of 256, which will tell us the range of usable IP. Now when we subtract 128 from the constant of 256, we get 128. Now we are going to add 128 to itself to get 256. Now when we get 256, we now calculate the different additions and we call them ranges. Now each of those ranges will represent our different subnets. Now for the first subnet, we are going to have 1 to 128. Now the first 1 to 128 in this particular scenario is assumed as the same as 0 to 127. Now in an IP address, we have a network portion and we have a broadcast address. We have a network address and a broadcast address. Now the first IP address is normally your network address and the last IP address is your broadcast. Now one thing you need to understand is that in this scenario, 0 is our network address because it's the first, and 127 becomes our broadcast because it's the last. Now with that, we're now left with a range of 1 to 126 as usable IP for the first subnet. Now for the second subnet, which is 128 to 256, alright? 128 now is the first IP address, which is our network address, while 255 is the last, which is our broadcast. Now you'll be wondering why we're not using 256. Now the reason why we don't use 256 is because there was a reduction when we went from 0 to 127. So that affected the rest. So now we have 128 to 255. So 128 is our network address and 255 becomes our broadcast address. Now, which leaves us with a range of 129 to 255, 254 as usable IP address for our second subnet. Now, you need to understand that the first subnet starts from 1 to 126 for usable IP, while the second subnet is having 129 to 254 for usable IP address. Now the first subnet has a network address of 0 and the last subnet has a network address of 128. Now the first subnet has a broadcast address of 127 and the last subnet has a broadcast address of 255. What does this mean? This means that with a network address of 192.168.1.0, I can be able to reach 192.168.1.1 till 126, alright? And the subnet mask remains the same, which is 255.255.1.128. While for the second subnet, with a network address of 192.168.1.128, I can be able to get to 129.2.254. So that is all you need to understand about IP address, and hope to see you in the next one.